Hello, myself Naveen Kumar Saini. In the course Microprocessor, and in that programming part, we will discuss about some basic program, and then we will come to the complexity of that one. So first program, that is the store the data byte 32 in hexadecimal into the memory location 4000H. So in the previous lecture, we have also discussed some of the programs which was carrying about the counter and delay concept. Okay, so in the previous case we have discussed how to generate the sum of the programs which is of 1 millisecond time delay and so on. So in the sequence of that one, we will come to the next programming part, that is 8085 microprocessor. So in that first one is very basic one, that is to store the 32 number into some of the memory location. This is generalized way, so which we can go through it. So in that few things which we have to take care about to understand how to program the our concept or algorithm. So first thing is we have to move the data. So data may be given into the program, or it may be we have to be considered that. Okay, so here specifically it is given into the program that 32 is the specific number which we have to store into particular memory location. So in that if the number is given into the program, in that case we have to use any of the immediate addressing mode instruction. So for that we have MVIA. This is immediate addressing mode, in which the number will be given into the instruction itself. So this number is nothing but this is the operand. So we know that every instruction is the two parts, that is opcode and the operand. So MVIA, this is the opcode part, and 32 is the operand. Because the number is given into the instruction, that is why this addressing mode is the immediate addressing mode. So by this expression we can come to know that 32 will store into the accumulator. Then we have two instructions, that is the LDA and the STA. So we must know the differences between these two. First is the LDA instruction and second is the STA. So both our instructions are used for storing the numbers. It may be from accumulator to the memory location, or from particular memory location to the accumulator. So here if we want to store the number into the particular memory location from the accumulator, so in that case we have the instruction STA 4000H. So this is a direct addressing mode in which the content of the accumulator will move into the memory location which is given specifically into the instruction. Okay, so if we have this type of instruction like the LDA, so this is opposite of that one, in which the content of the memory location will be stored into the in the accumulator. Okay, so this difference we have to be take care about whenever we write the any of the program. Then the last, that is the HLD, halt. So in when we type into the any 8085 microprocessor kit, then we never write the HLT, we simply write the RST. Any software interrupt we can write. Okay, so this is the example to end up any of the program. Second method is for the same program we can write it. If we are writing the LXI H 4000H, so it means this 4000H will store into the HL register pair. Okay, so in this case HL pair is equal to 40000H. Then MVI M comma 32. So this M is representing the immediate previous immediate memory location. So in this case M is nothing but is a 4000, so we can write it as the M. So this is memory location and this is also equal to M. So it means this 32 number or the operand will move into the M location. So it means that 32 will in the memory location pointed by the HL pair register, in which the 32 bit will be stored into that particular memory location. Then we have next program, that is exchange the contents of memory location 2000H and 4000H. So we have to just exchange the memory location, this contents of that. So for this one we can start it from the LDA. In the previous case, as we said about the, this is the opposite of the STA. So in that LDA instruction, what it says, LDA 2000, what is the meaning of this? That the content of this memory location will store into the accumulator, right? So this is nothing but this looks like this. The content of this memory location will move into the accumulator. So this memory location and then into the accumulator. Then move B comma A means the content of A will move into the B B register, because we are exchanging the numbers from the memory locations. Then so it means so in suppose we have some number, suppose we are saying this number is 32, just for example. Okay, the content of this memory location is carrying the 32. So we can say if this is our memory location, and at this memory location we have 2000, and in this we have the 32 number, and after LDA instruction, LDA 2000, so content of this 2000 will move into the mu p, and this mu p will carry the accumulator content, that is 32. Fine. Move A comma B. So this B A content will move into the B register. So B register will carry the 32. Now 32H. Then LDA 4000. So now the content of 4000. So in that, if you are saying the 4000 content, it is this value is your 20. Okay. So what it says, the 4000 content will move into the accumulator. So this 20 will move into this accumulator. Now this A will 32 bit will 32 will replace by the 20H. So it means A is equal to 20 will be there. Now because 32 is copied into the B register, so B register will carry 32H, and A contains the 20H. Then STA 2000, it means the content of accumulator will move into this memory location of A. So this content of A will move into this memory location. Now this one will carry the 20. Fine. Then move A comma B means content of B will move into the accumulator. So content of B will move into this accumulator. Now again the A will carry the 32. Okay. Then STA 4000 means content of A will move into this memory location. So it means this 32 will move into this memory location. So it means this carry the 32H. Okay. So it means this numbers from the memory location 2000 to 4000, this is swapped. From 20 is moving here and 32 is moving here. So this is the way how to exchange the numbers from the particular memory location. So then it is a halt. So this is a very simple program which is to exchange the contents of memory locations, which is given 2000 and 4000. Next is to find the ones and twos complement of the number which is stored at the memory location 4200H, and store the complemented number at the memory location 4201H and 4202H respectively. Means the number which we are providing at input is at the 4200, and the ones complement at the number which is given here, it will store into this, and the twos complement of this number will store into this. So in this, the ones complement will store into this memory location, and twos complement at this memory location. So how we must be aware how to convert that. Suppose we have any number 32H which is stored at the memory location 4200H, okay, at this memory location. So 3 we can write it as 0011, and 2 we can write it as 0010. So this is the 32H in the binary form. Okay, so when we do the ones complement, so ones complement is nothing but this 0 will become 1, 1 becomes 0, 0 become 1, 0 become 1, 1 becomes 0, 1 becomes 0, 1, 1. So this is the ones complement. Okay. Now if I want a 2's complement, what I will do, simply we will add 1. So this value 0, 1 here, 1 here, then 1 1 0 0 1 1. Okay. So it means this number will be stored, this is the 2's complement. This is, so what is the concept in that? So whatever number we are giving at the 4200, so this number will be into the 1's complement when the 0 is converted, when the zeros will be 1 and 1's will become 0. So it means simply we have to complement this number. So when we complement this number, this is the 1's complement. When we add the 1 into this 1's complement, we will get the 2's complement. So it means we have to add 1, right, for the 2's complement, and simply complement the number which is given at the particular location. So let's see, LDA 4200H, the significance of this, the content of this memory location 4200 will store into the accumulator. So it means this 32 will store into the accumulator. Okay. So this 32 will store into the accumulator. So at this point, accumulator have the 32. Okay. Then CMA, this is nothing but this is for the complement. So we are applying the instruction, that is CMA here. CMA, complement the number, then the complemented number is this one. Now we want to store this number which is at the accumulator into the memory location, that is 4201. So we want to store this one in the 4201H. Okay. So we have this instruction for that particular case, STA 4201. So the content of accumulator will move into this particular memory location 4201, which is our requirement. Second is 2's complement at this location 4202. So for that one, what we need to do, simply we have to add 1. We have to add 1 for the 2's complement, and result will store into the memory location, that is 420. Okay, so this was the 1, this was the 4202H. So for that we have another immediate addressing mode, that is ADI 01. So we are simply adding the 01 here. So how we add this? Okay, I will show you. 01 will be 0 0 0 0 and 1 will be 0 0 0 1. Okay, so this is simple addition 0A. So this is the 01H. Okay, fine. So now simply add ADI 01H, then this addition will be into the accumulator as well. So now we have the STA 4202. So it means the content of accumulator A will move into this particular memory location, that is 4202. So in this way, this three memory locations are required: 4200 for the input, 4201 for the output for 1's complement, and 4202, this is the output for the 2's complement, and at the end halt. Okay. Now come to the next one. Add the content of memory locations 400H and 4001 and place the result in memory location 4002. Again, this is very simple. LXI-H, we are using the immediate addressing mode, that is LXI-H 400H, in which we will use the 1 of the content. Okay, so in this memory location 4000H, we have one number. Suppose this number is 30. Okay, and then second memory location 4001H, we have another number 32H. Okay, then place the result in the memory location 4002. So it means the addition of these two numbers must be stored into this memory location. So it means first content we have to put it into the accumulator, second content will be into any of the register of the memory location. So we are aware that when we add the numbers, the add, suppose here I take the M, so this is nothing but this is equivalent to A plus M is equal to A. Okay, So content of accumulator, content of memory location will add the into the particular memory location into the accumulator. So LXI H400H, it means the HL pair at this point. HL pair will carry the 4000H. Move A comma M, as I said, the HL pair is nothing but this is M. Then content of M will move into the accumulator. So content of M, we can see it from here. This content is 30. So it means the accumulator contains the 30H. Okay. Then INX H, it means increment the HL pair. So now for this case, when we increment the HL pair, the HL pair will become HL pair plus 1. So this value will be 4001H. So we have incremented this number. Now we reached at this point. Then add M. So now at this point the HL pair value is M, that is 4001H. Previously it was the 4000H. Then now HL pair incremented by 1. So value of M will become 4001H. Okay. So now next is add M. So when you apply this, again the same thing is here. A add M, that is A plus M is equal to A. So content of A, we can give the two inputs. One input is into this into the accumulator, and second input will be into this memory location. So so in this case the first is the 30 and second one is the 32. So this is in the hexadecimal. So this value will be your 62. So this is the addition. So these numbers are stored. We want to store, this is into the accumulator right now. So now what we want to store the content of accumulator at the memory location to 4002H. So for that one we have the instruction. What is okay? So we can use this instruction that add M INX H. So we are at this point the value of M is what? M will become 4001 plus 1 because this is the increment, right? So increment of this one will become 4002H. So this is the updated HL pair register. Okay. Then move A comma M. So M comma A. What is the meaning of this? The content of the accumulator will move into the memory location which is specified by the just previous HL pair register. So this time this is a 4002H. Or another method for this one is we are getting the value of M. So right now we have the A, this is 62. So directly we can put into the 4002H. So what instruction we can apply in place of this? So we can use the STA. So we can use STA. So STA, that is your 4002H. Because this is in the sequence, that is why we are using the INXH. If we don't want to use it and we want to put the value of A into particular memory location, so we can use STA 4002H. Or if you want to store this number at 500H, in that case, in place of 4, we can use the 5000H. Okay. So as per requirement, we can change the memory location at which we want to see or we want to store the content of the accumulator. So that is STA 4002 or 5000. This is as per the requirement. And then HLT, this is for the termination of the program. Then we have to find the largest number in a given array of data using the 8085 instruction set. So in this case, for the largest number, we have to use a comparison. So comparison of the 5 numbers, okay, or the 4 numbers, 3 numbers, whatever we want. So suppose we want to compare the 3 numbers. Maybe this number is 20H, 30H, 40H. Okay. So these 3 numbers we can see. So in that case, suppose we have a data array. We have a data array of 3 numbers. So in this case, So in this case, how many comparisons are required? So total comparisons is n minus 1. So if n is the data size and n minus 1, so in this case how many comparisons are required? In this case n is equal to 3. So this is 3 minus 1 is equal to 2. So 2 comparisons are required. So what we will do, we will start it from the LXI H2500H. So what it shows that the content 2500 will store into the HL pair. So at this time HL pair is equal to 2500H. Okay, then move C comma M, the content of M will store into the C register. So at this time we are giving the inputs. The 2500 is used for giving the input and numbers, the count. This count will be stored into the C register. So at this time C register will carry, because n is 3, so we are giving the C is equal to 3 right now. INX H, so we have just incremented. So here, so this is for the memory location 2500, and this memory location is for the 2501. This is for 2502, for 250. So in this way we can use these memory locations. So we can let's see INX H. So at this time HL pair value is 2501H. Okay, move content of M into the accumulator. So 2501 contains a 20H. So 20H will be stored into the accumulator. So accumulator value, that is 20H. Then DCRC, because the comparisons what are the comparisons are required? It requires the n minus 1. So 2 comparisons are required. So this is the content of C is decremented by 1. So at this time the value of C is equal to 3 minus 1 is equal to 2. Then increment H. So now we have incremented H, that is 2501. So at this time this HL pair will carry the 2502. So why we are doing this? Because we have to compare these two numbers 20 and 30. So two inputs we are providing. One is at the memory location 2501, second at the memory location 2502. So when we compare these two numbers, so this comparison will be in 3 types. Obviously, if A is less than M, A equal to M, or A greater than M. So what is the so when we use the comparison instruction, so by using the comparison instruction, only the flags will be affected. There is no effect on the accumulator. So if A is less than M, so it will, comparison is nothing but we are doing A minus M within the system, but it will not be affect the accumulator. Only the flags will be affected. Okay, so in this case A less than M, it means A is less than M means carry will be generated. So it means the carry is 1. A is equal to M, so in this case the 0 flag will be set. A greater than M, in that case the carry flag will be 0. Okay, so these flags will be affected by the using the comparison instruction. So let's see A and M. So in this case A is this one and M carry the 30. So when we do the A minus M, so in this case 20 minus 30. So what it shows that it shows that the carry flag will be 1. Okay, because the borrow is generated, so carry flag will be 1. So now let's see the J and C. What it shows, J and C, jump if not carry. So true condition is if the carry is 0, right? But this is the case when the carry is 1. Then what will happen? It will come to this one. So move A comma M. So content of M will move into the accumulator. So what it shows, the content of M will be stored into the accumulator. So content of M, what was that? This is 30. So at this time accumulator will be replaced by the 30. So 30 is the number which we have to be compared, because 30 is the largest number out of the 20 and 30. So this 30 will be stored into the accumulator. Now again the decrement C register. So C was 2 here, now C will become 1. Okay, because previously it was a 2, now it is decrement by 1. So in this case 2 minus 1 is equal to 1. So now then come to here J and Z, jump if not 0. What is not 0? Just about the previous instruction. So C, if the C register is not 0, then in that case this will come to the loop. So where is the loop? Here. So INX H, so it means increment the HL pair. So now HL pair is 2503. So what is the content into the HL pair? That is 40. So it means accumulator contains the 30 and the M contains the 40. So it means A is 30 and M is 40. So again the comparison will occur. So when the comparison is occur, so in this case we see the 30 minus 40, it means the carry flag is 1. Again carry flag is 1. When the carry flag is 1, then in that case J and C, jump if not carry. It means the jump if not carry. So this is the false condition. When it is the false condition, again it will come out of this loop. Then the content of M will store into the accumulator. So what is the content of M? That is the 40. So this 40 will store into the accumulator. So right now the content of accumulator is 40. Decrement C. Now C will become 0. Previously it was 2, then 1 and then 0. Then as J and Z, it means the content of C register is 0. So what it shows, that jump if not 0. True condition is if jump if not 0, then it will jump to the loop. But in this case the C register is 0. So this is the false condition. So it means this will come out from the loop. And STA 2450. What is the meaning of this? The content of accumulator will move into this memory location 2450. So it means the content of the accumulator is what? This was the 40. Okay, fine. So it means the 2450. So this number will this content will store into the 250 location. So the largest number will store into in that way. Clear? So because at this time, what is the value of accumulator? That was the 40, and this 40 will store at the 2450. So 40 is the largest number out of 20, 30 and 40, and this 40 must be out into the particular memory location which is given 2450H. So this is the end of this program by using the halt. But this was the largest number. Suppose just if we want is the smallest number, so what we will do, so there is nothing much doing into this, just simply use the JC instruction for this case. Okay, so JC instruction, by using this one, then when we compare it, then only the content of the smallest number will be come out from this result, and it will store into the particular memory location. Okay, so the memory location we have to give for this case. Okay, so we are using the conditional jump instruction here. Okay, so conditional jump we are taking it. If we are not using the conditional jump, then it will regularly or infinitely iteration will occur, and it will go to the locations which is specified for that. So that is why we have to use the conditional jump. Then we have to write a program using the 885 microprocessor for hexadecimal addition of two numbers. So for that one, simply as we had discussed previously, that we use the LXI H2501, and this content this HL pair carry the 2501 and move M A comma M. The content of M will be stored into the accumulator. So then increment H, at this time HL pair will carry the 2502 and add M. So this is again A plus M. So these two numbers will again add and store into the accumulator. Then the content of accumulator will move into the 2053H. Then the last example is for the multiplication. So I will just give you the algo for that. So because we know that there is no instruction like multiplication into the 885 microprocessor, but we have it is available in the 86 microprocessor instruction set. So in that case, simply just use it. Suppose we want to multiply the 03 and 08. So for that one, the answer must be in the decimal 24H. Okay. So what you need to do, simply you just add these three numbers. So answer must be same. So try this. If you're finding any issue, you can comment on my chat comment box, then I will try to solve it. Thank you very much.